Alright y'all, coming at you with a 7-6 example video, working with dilations and similarity in the coordinate plane, which basically means that we're using them on shapes, using dilations and scaling on shapes. More specifically, similar shapes, so these shapes being similar, we can use proportions to solve for the dimensions of those other shapes. So our first example is this one with triangles TOU and ROS, sorry, ROS. So we're going to find the coordinates of U, and we're going to find the scale factor of these two triangles. So what we're going to do to start is think about which corresponding measurements we have. So I see that T is -9, which means that it's 9 units that way, right? And then R is -12, which means it's 12 units that way. So 12 units backwards and 9 units backwards. And so that can be represented in a proportion, right? Like this, -12 over -9. And now that we've established that -12 is on top, we got to make sure that the bigger triangle's dimensions stay on top in our fractions, okay? So we got to make sure that the top matches up to the top and the bottom matches up to the bottom. And this is point T and R, and this is going to be Y and U. So what's going on top? Is it going to be 16 or is it going to be U? It's probably going to be 16 because that's the big triangle measurement that we're working with. And so 16 is going to go on top over here. And then on bottom is going to be the distance from here to U, which is our unknown. So we don't know that measurement, so we're going to assign a variable to it, good old classic X. And now for the cross multiplication, we'll multiply -12 times X and 16 times -9. So -12X equals -144, I believe. And so now that we've got that, we can solve for X. We'll divide by 12 on each side, or -12 on each side, and we'll end up with X equals 12. And so let's think about, does that make sense for our U measurement? If this is 0, 12. So this one, we went back 9 in the small triangle and 12 in the big triangle. And in this one, we went up 12 in the small triangle and 16 in the big triangle. So I'm thinking about those. I feel like that's pretty reasonable. Like that makes sense in my head. We're not going up past this one, and it's not super short down here either. So this answer feels right, and if I wanted to check it, I could simply put it in there, divide 16 by 12, and this is how we're going to get the scale factor too, so you might want to pay attention to this. But to check it and find the scale factor, we'll simply divide one of these by the other. So scale factor, SF, equals -12 over -9, which is equal to 4 over 3. So that's going to be our scale factor, and that's going to be the coordinates of U. All right? So there's one example. And then if we go down to the next one, we are given a couple of points, which I'm going to put on the graph real quick. So we've got X is 0, 2. So 0 up 2, or over 0 up 2. And then we've got Y is left 2 and up 2. And then Z is left 2 and up 0. And so that's our... It doesn't necessarily say it's a triangle, but we can connect these just so that it's easier to visualize. Not to brag, but I think that was a perfect connection. Anyway, so we're going to find the coordinates of X prime, Y prime, and Z prime after a dilation with a scale factor of -4. So that means that we're going to multiply all of those previous coordinates by -4, okay? And to do that, write all of them right here. So we had 0, 2, negative 2, 2, and negative 2, 0, right? And so if we want to use a scale factor on this, if we want to dilate it with a scale factor of negative 4, we're going to multiply each value, each coordinate by negative 4. So negative 4 times 0, I'm just going to write in here negative 4 times, just so that we have it written down. Negative 4 times 0 is 0. Negative 4 times 2 is negative 8. Negative 4 times negative 2 is positive 8. And negative 4 times positive 2 is negative 8. Negative 4 times negative 2, again, positive 8. And negative 4 times 0, again, is 0. So now, here is our new coordinates. So we had x, y, z, and now we have x prime, y prime, and z prime. And so now that we have these points, we can go ahead and graph them. Well, actually, it just asks to find the coordinates. So these are the coordinates of x prime, y prime, and z prime, but we can see what they do to the triangle in the graph. It's not quite big enough to fit everything, but we've got 0, negative 8, so negative 8 is down here. We've got 8, 0, and we've got 8, negative 8. So our new triangle would look something like this after being dilated by a scale factor of negative 4. So here's our original, and here's our new one. And that is the example for section 7.6. Peace out.